Yesterday we had a really exciting flight. We came from Kona in Hawaii and we flew across the equator and came down to American Samoa. When we crossed the equator, we went through a part of the atmosphere that's just amazing to see. It's called the Intertropical Convergence Zone. It's where the northern hemisphere air meets the southern hemisphere air. It's really the engine that drives the dynamics of the atmosphere.
The Intertropical Convergence Zone is a really special place on the planet. What you do is you get a lot of heat and it's warm at the equator and there's a lot of moisture down low, and this just causes air to rise. So you get this air rising, but then that sucks in air from the northern hemisphere and the southern hemisphere. As you rise, it's just like a fountain. You get air spreading at high altitudes. So it's a really cool part of the atmosphere. Now, one of the fun things that we did is we flew right down the equator. So one wing of the airplane was in the northern hemisphere and the other wing was in the southern hemisphere.
And we were expecting to see quite a contrast between the air in the northern hemisphere and the southern hemisphere. We expected the air to be pretty clean in both places because we're out in the middle of the Pacific. But, you know, the models that we were running had forecast that there would be some pollution from South America right in the equatorial regime. And we actually did see that. It was kind of shocking to see it. So there's benzene in the atmosphere and such from burning of the agricultural lands and forests of South America. It was also a challenge to perform this flight altogether. So big thunderstorms that kind of pop up and drive a lot of the dynamics of the atmosphere. And these storms aren't easily predicted, and we have to get the airplane through there. And the crew did a fabulous job of figuring out how to get through there and how to make these measurements really work.
Today, we're here in Christchurch, New Zealand. We're here in Christchurch because we're profiling through the atmosphere, making measurements, because we want to understand what's going to happen to the atmosphere in the next 20, 30, 50, 100 years. What's in store for the future? By taking a picture of the atmosphere now, we're hoping to project what will happen using models that are constrained by all of these observations. Now, when we flew up here, we flew through this tremendous jet stream and this deep convective region called the South Pacific Convergence Zone. Now, when we profiled on one side, we had a certain chemistry that was going on, and then we jumped over this jet and all of this strong convection and rain. We got on the other side, it was clear skies on the other side, down towards the south, towards New Zealand here, and it was completely different chemistry that we were seeing. And so this is the sort of thing we're exploring right now. How is the tropics different from the mid-latitudes, which is different from the high latitudes in the southern hemisphere? Once again, greetings from the ATOM project, and our next stop will be Punta Arenas, Chile.